The secret at the edge of the universe. Does another you really exist? In the darkness of night, when you lift your head to the sky, what do you see? Perhaps a few bright stars, the familiar face of the moon, or if you're lucky, the hazy band of the Milky Way. What we see is the cold glimmer of infinity. It is an enigma that has inspired poets, perplexed philosophers, and driven scientists throughout human history. We are but a tiny grain of sand on the shore of this vast cosmic ocean. The diameter of the universe we can observe is approximately 93 billion light-years. This is a distance that challenges the limits of our minds. It would take light itself 93 billion years to travel from one end to the other. Within it are hundreds of billions of galaxies, and within each galaxy, hundreds of billions of stars. The numbers begin to lose their meaning, don't they? This is our everything, our home, our history, our future. Everything resides within this colossal bubble. But what if everything we see is just a single book or even a single page in a gigantic library? What if this 93 billion light-year cosmic bubble is merely a small fragment of a much larger structure, one we cannot even imagine? This thought may seem like something out of a science fiction film, yet today, the world's brightest minds, physicists and cosmologists are seriously debating this possibility. They are searching for the crumbs of evidence and theoretical clues that lead us beyond our universe into the mind-boggling world of the parallel universes, or multiverse hypothesis. This opens the door to a question far deeper than are there other living beings in space? Are there other universes? And in those universes, could there be other versions of us? To embark on this incredible journey, we must first return to the beginning of our own universe, to the moment it all began. Approximately 13.8 billion years ago, our universe was born from a point of singularity, incomprehensibly hot and dense. This event, which we know as the Big Bang, was not just an explosion, but the very creation of space and time itself. From that moment, the universe began to expand, and it is still expanding today. Galaxies are constantly moving away from us and from each other. How do we know this? By listening to the oldest light in the universe, the very echo of creation. This light is known as the cosmic microwave background radiation. These first photons, which spread out in all directions when the universe was only 380,000 years old, now present us with a baby picture of the cosmos. And this picture is almost perfectly smooth. The temperature is nearly the same in every direction. This is one of the strongest pieces of evidence for the Big Bang theory, almost perfect. But not quite, and this is where the mystery begins. When scientists mapped this cosmic background radiation in detail, they noticed some peculiarities or anomalies. The most famous of these is the cold spot, located in a region of the southern sky, which is abnormally cold compared to its surroundings. This spot is larger and colder than it should be according to standard cosmological models. Scientists have been trying to explain this anomaly for years. Perhaps it's just a statistical coincidence, or maybe it's something much more. According to a hypothesis proposed by some bold theorists, this cold spot might be a scar, a cosmic bruise, left behind from a collision between our universe and another bubble universe billions of years ago, the fossilized moment when another reality beyond the boundaries of our own universe touched ours. This idea takes us directly to the heart of multiverse theories, and these theories are not all under one roof. There are several different multiverse models based on different physical foundations. Let's start with the simplest. If our universe is spatially infinite, then a multiverse is inevitable. Imagine that our observable universe is limited only by the cosmic horizon, the maximum distance from which light has had time to reach us since the Big Bang. What lies beyond this horizon? Most likely, more space, more galaxies, more stars. If this space extends infinitely, then we are faced with a sea of possibilities where anything is possible. Although the number of ways particles can be arranged is immense, it is finite. In an infinite space, these finite arrangements must repeat themselves. What does this mean? If you go far enough, you will find a galaxy identical to our Milky Way. If you go even further, you will encounter a copy of the solar system. And yes, if you go far enough, the probability of encountering another planet with an exact copy of Earth, the city you live in, and even you, is theoretically not zero, that you might be watching this documentary right now. Or perhaps they made a completely different choice in their life and took a completely different path. This is an idea as it is unsettling. A second, more popular model is the idea of bubble universes, which arises from the eternal inflation theory. According to this theory, the Big Bang was not a one-time event. Rather, space-time itself is like a constantly expanding, bubbling ocean. In some regions of this ocean, the expansion slows down and a pocket universe, or bubble universe like ours, is formed. But elsewhere in this cosmic ocean, inflation continues, constantly giving birth to new universes, countless disconnected universal bubbles. The most striking aspect of this model is that each bubble could have its own fundamental laws of physics. In one universe, gravity might be much stronger than in ours. In another, the speed of light could be much slower. Most universes would likely be too chaotic and unstable for life to form. But among billions, perhaps an infinite number of bubbles, it would not be surprising for a universe like ours to emerge by chance, where the physical constants are finely tuned to allow for the flourishing of life. The reason we are here is not that the universe was specially designed for us, but that we simply exist in one of the habitable ones. This is known as the anthropic principle. The person who wins the lottery is surprised, asking, "Why did the numbers come up exactly as I played them?" But there are millions of losing tickets. We live in the universe with the winning ticket. However, the most mind-bending, the most confounding multiverse model comes from the smallest scale of physics, quantum mechanics. In the 1950s, a physicist named Hugh Everett proposed a radical solution to the strangeness of the quantum world. According to quantum mechanics, a particle can exist in multiple states at once. Superposition, as long as it is not observed. For example, an electron can be both here and there at the same time. The moment we measure it, only one of these possibilities becomes real. So, what happens to the other possibilities? According to Everett's many worlds interpretation, the other possibilities do not disappear. They also become real, but in a different universal branch. Every measurement we make, every step we take, every decision we make, splits the universe into countless copies. Consider Schrodinger's famous cat experiment. A cat in a box is both alive and dead, depending on whether a radioactive atom has decayed. When we open the box, we find the cat either alive or dead. According to many worlds, the moment we open the box, the universe splits in two. In one, we find the cat alive. In the other, a copy of us finds the cat dead. Apply this idea to your life. The moment you chose tea instead of coffee this morning, another you, who chose coffee, may be continuing their day in a completely different reality. When you made that major, life-altering decision, the you who chose the other option is now living a completely different life. According to this theory, an infinite number of parallel realities are being created every moment, every second. An infinite tree of our choices, possibilities, and paths. On one of these branches, there may be a version of you who has achieved your greatest dreams. On another, a different you has faced your greatest fears. All these universes are equally real. We cannot switch between them because each is a closed system unto itself. But if this theory is correct, what we consider reality is just a single wave in an infinite sea of possibilities. Finally, we come to string theory, the most ambitious and as yet incomplete theory in physics. This theory proposes that the fundamental building blocks of the universe are not point-like particles, but tiny, vibrating strings of energy. One of the most interesting consequences of this theory is that our universe may have more dimensions than the three of space and one of time that we know. These extra dimensions may be curled up on scales too small for us to perceive. Another exciting possibility is brain cosmology. According to this idea, Our three-dimensional universe is nothing more than a giant brain floating in a much higher dimensional space, the bulk. And in this higher dimensional space there could be other brains parallel to ours, other universes. Perhaps they are mere fractions of a millimeter away from us, but because they are hidden in those extra dimensions, we can never see or interact with them, with one possible exception: gravity. According to some theorists, gravity, unlike other forces, might be able to leak between these brains. In fact, the Big Bang that started our universe could be the result of two parent brains colliding billions of years ago. If this is true, anomalies in the cosmic microwave background radiation, like that cold spot, could be the remnants of such cosmic collisions. So, are all of these just dizzying theories? Or is there a way to test these claims? Science demands proof, not speculation. Currently, scientists are working with all their might to find this proof. Telescopes like the Planck satellite are scanning the anomalies in the baby picture of the universe with unprecedented precision. Gravitational wave observatories like LIGO might one day detect the ripples in spacetime caused by the collision of two brain universes. If physicists working at particle accelerators like the Large Hadron Collider detect that some energy disappears during collisions, it could be a clue that this energy has leaked into extra dimensions we cannot perceive. There is no definitive proof yet, only tantalizing clues, elegant mathematical equations, and bold ideas that push the limits of the human mind. Perhaps all of these ideas are wrong. Perhaps our universe is all that exists, and there is nothing beyond it. This is a simpler and less unsettling possibility, but what if it isn't? What if one day, scientists find concrete evidence to support one of these theories? Our entire understanding of humanity's place in the universe would be fundamentally altered. We would understand that we are not special or unique. We would be just one of the lucky tickets in an infinite cosmic lottery. We would have to cope with the philosophical burden of knowing that our choices are not final because every possibility is being lived out in another reality. So the next time you look at the night sky, don't just see the distant stars and galaxies, see the possibilities. Try to listen for the whispers of other worlds, other realities. Perhaps right beside us, behind a veil of perception, there is a universe operating by completely different rules. Perhaps in the depths of infinite space, someone who looks like you, feels like you, but is living a different life, is looking at the same sky at the same moment and asking the same question. Is our existence just one note in this immense cosmic structure? And as we search for our own reflection among the billions of stars in that darkness, perhaps the real question we should be asking is this: which of these universes is truly the main story? And where do we fit into that story? And in the silence, a question echoes: which is the main story? Are we a ship drifting on the waves of countless possibilities? Or are we just a single leaf on a giant tree whose roots extend into infinity? Our quest for answers to these questions forces us to look not only into the depths of outer space, but also at the most fundamental building blocks of existence, the very fabric of our own reality. What makes the idea of a multiverse so appealing is not just the possibility of other me's, but the elegant, almost poetic solutions it offers to some of the unexplainable oddities in our own universe. The most important of these is known as the fine-tuning problem. Imagine you are laying the foundation of a house. If you get the ratio of materials wrong by even a single milligram, the entire structure collapses. Our universe seems to be constructed with just such precision. If the constant that determines gravity were slightly stronger, stars would have burned out too quickly, and the universe would have collapsed back in on itself shortly after its formation. If it were slightly weaker, gas clouds would never have come together to form the first stars and galaxies. If the value of the strong nuclear force within the atom's nucleus were different by just 1%, elements essential for life, like carbon, would never have existed. And perhaps the most mysterious of all is the energy of space itself, the cosmological constant. Our theoretical calculations suggest this value should be incomprehensibly larger than what we observe by a factor of 10 to the power of 120. That means adding 120 zeros after a 1. If this theory were correct, the universe would have torn itself apart the instant it was born, but it didn't. Somehow, this value remains at a level so small, so close to zero, that it allows life to exist. Why? Why does the universe balance on a knife's edge to allow for life's existence? There are two primary perspectives on this cosmic coincidence. The first accepts the existence of some kind of superior designer. The universe was fine-tuned for us to exist. This belief, which falls outside the realm of science, is a subject for philosophy and theology. The other is the statistical inevitability offered by the multiverse hypothesis. If there are an infinite number of universes, each born with different physical constants, the overwhelming majority of them would be chaotic, dead places that disappear in an instant. However, within these infinite trials, it is logical that a universe like ours, where all the settings are just right, would emerge by chance. The very fact that we are asking this question is proof that we live in the right universe. We didn't win a cosmic lottery. We simply opened our eyes in one of the countless universes where only winning tickets are printed. The cold, chaotic, and meaningless universes exist and vanish in silence because there is no one to observe them. Ours sings silence. This idea takes the responsibility off our shoulders and places it on the cold shoulders of statistics. But the many worlds interpretation, born from quantum mechanics, places responsibility and creation right back at our center, upon each observer. According to this theory, when you face a moment of decision, for example, deciding whether to turn right or left, the universe doesn't simply split in two. In fact, all possibilities already exist as a whole of potentials in a quantum foam. Your consciousness, by making a choice, experiences one of these possibilities and makes that path your reality. The you who chose to turn left proceeds on that branch of reality, while the other you who turned right continues on their own path. This shows that destiny is not a single line but an infinite garden full of forking paths. Free will is the act of choosing which path to walk in this garden. Each path is as real as any other. This leads us to a discomforting conclusion. There is no life that was never lived, no choice that was never made. Your what-ifs are the reality for another you in another reality. So where are these universes? Are they billions of light years away from us like the other bubbles in the cosmic ocean? Or are they right beside us at every moment, beyond our dimensions? This is where a derivative of string theory, the holographic principle, shatters everything we know about reality. According to this principle, everything we perceive as three-dimensional could be a projection of information encoded on a two-dimensional surface at the boundary of our universe, just like a hologram on a credit card. A hologram is a two-dimensional surface, but when light hits it at the right angle, it creates a three-dimensional image. What if our universe is such a projection? What if we are three-dimensional avatars created by a complex encoding on a giant cosmic disk? In this case, the concepts of here and there lose their meaning. We wouldn't need to look outside to search for other universes. Perhaps other realities are simply different sets of information encoded on the same fundamental surface beneath the resolution, the pixels of our own reality. This is the most speculative, most philosophical area of science, but it whispers to us that the proof we seek may not be hidden in the lens of giant telescopes, but in the very fabric of space-time, in emptiness itself. One day, when we fully understand the nature of gravity, perhaps we will discover that it is a messenger of information, traveling between different holograms, between different realities. What would the discovery of these possibilities mean for humanity? Would we collapse under the weight of such knowledge, or would it carry us to a new enlightenment? On one hand, the meaning of our individuality and our choices could be shaken. If the opposite of every choice I make happens somewhere else, what is the importance of my choice? This could lead to a deep sense of meaninglessness and nihilism. Life would become a game with infinite copies. But there is another side to the coin. This knowledge could make us more humble than ever before in our history. The fact that our species, our planet, and even our entire universe are not unique would shatter our cosmic arrogance forever. Moreover, it could also eliminate our sense of loneliness, even if we cannot reach them, knowing that there are countless versions of us living different adventures, learning different lessons. This could create a sort of cosmic family feeling, knowing that there are versions of us experiencing our greatest triumphs as well as those making our most tragic mistakes. Could it increase our capacity for compassion and understanding? We could learn to look at the mistakes and regrets in our own lives as just one path in the infinite tree of possibilities. We would understand how precious and unique the reality we experience in that moment, our conscious awareness in that moment, truly is. Because there may be infinite possibilities, but you are only living this moment in this body, and that makes it the most precious thing in all that infinity. Our journey has taken us from the largest scales of the universe to the strangeness of the subatomic world, and from there to the deepest questions about the nature of consciousness and reality. We still don't have definitive answers. We only have an expanding horizon of understanding, sharper questions, and an insatiable curiosity in the pursuit of truth. We may be like members of a tribe living on their own small island, unaware of the ocean's existence. We do not yet know whether the fog on the horizon is a sign of another landmass or just a weather phenomenon. Perhaps these parallel universes will remain an eternal mystery. Perhaps our instruments will never be sensitive enough to detect them, or our minds are ill-equipped to grasp this reality. But maybe not, maybe tomorrow, a data signal from the Large Hadron Collider, an unexplainable anomaly appearing on a screen at CERN, will change everything. Perhaps that proof will be the faint trace left by a particle that momentarily leaked into another universe and returned. Until that day, we will continue to look at the night sky, and now we will see not just stars, but stories. The infinite stories that were started but not finished, chosen but not lived, dreamed but not forgotten. We are looking for a mirror to see ourselves. But perhaps the universe is offering us a foggy window, and when we look out that window, we cannot be sure if the silhouette we see belongs to an inhabitant of another universe, or if it is just our own reflection, looking back at us in that moment. The search continues, and then silence, the void that remains after the ghostly image of billions of universes, each carrying its own truth, each a point of infinite light. The mind naturally recoils from such an idea. It denies it, because this is the greatest slap to the human ego, the possibility that we are not even the sole owner of our own reality, let alone the center of the universe. But even if the mind retreats, physics does not stop. Mathematics is not afraid. The search continues right at the edge of this dizzying precipice, asking ever stranger and deeper questions. If that infinite number of points of light is real, then how thick are the walls between these realities? And what is the fundamental principle that builds these walls? The answer to this question may be hidden in one of the most provocative ideas of recent years, in the very nature of reality itself, information. The image on your computer screen, a voice on your phone, the letters in a book. They are all fundamentally information encoded in bits and bytes. What if the universe itself is like this? What if atoms, stars, galaxies, and even our own consciousness are the outputs of a vast cosmic operating system? This draws us into the waters of the simulation hypothesis. This idea, once the domain of science fiction writers, is now a possibility taken seriously by some physicists and philosophers. Why? Because our universe behaves in a strangely programmed way. It has rules. The software codes we call the laws of physics, and when we dig deeper, there are clues that space-time itself might not be smooth and continuous, but composed of the smallest indivisible units called the Planck scale, a kind of cosmic pixel. If a sufficiently advanced civilization exists, they could create a simulation of their own universe. And could the conscious beings inside that simulation, upon becoming sufficiently advanced, create their own simulations? This creates a cascade of realities, like an infinite series of Matryoshka dolls. In this scenario, the probability of us being in the base reality is almost zero compared to the probability of being in one of the billions of simulated realities.
Parallel universes, in this case, could be different programs running on the same master server. Our universe is one program, the one next to it is another, perhaps another one is in beta testing. Who or what could be the beings running this simulation? Does time flow for them as it does for us? Perhaps our 13.8 billion years of universal history is just a calculation completed for them in a matter of seconds. And anomalies like the cold spot in the cosmic microwave background radiation. Perhaps they are a bug in the system, a software error, or maybe the trace left by the system administrator's mouse cursor. This idea is as terrifying as it is a completely different solution to the fine-tuning problem of the universe. The universe is fine-tuned for life because it was programmed that way. Perhaps one of the most fundamental differences between these different programs, or universes, could be the nature of time itself. In our universe, time is an irreversible arrow flowing from past to future. The reason for this is entropy, one of the most fundamental laws of physics, the tendency of the universe to move continuously from order to disorder. We don't see a broken glass reassembling itself. The past has low entropy, the future has high entropy. But what if this arrow points in a different direction in other universes? If there are universes like ours, expanding from a big bang with increasing entropy, perhaps there are also universes heading towards a big crunch, contracting with decreasing entropy. In such a universe, time would flow backward for us. Broken glasses would reassemble, people would grow younger instead of older, and life would be lived from end to beginning. How would we even comprehend a signal, a message, from such a universe? Could we grasp a logic where the effect precedes the cause? This brings us to the most crucial question. If these universes exist, is a transition, a whisper, an interaction between them possible? According to our current understanding of physics, the answer is largely no. These universes are either too far from us, locked in different dimensions, or have a completely different causal fabric. But largely does not mean completely. There are always cracks in the frontiers of science, always what-ifs. One of the strangest phenomena of quantum mechanics, entanglement, allows two particles to remain instantly connected no matter how great the distance between them. When the state of one is measured, the state of the other is instantly determined. Einstein called this spooky action at a distance. What if, at the moment of the Big Bang, a particle in another bubble universe, born along with ours, remained entangled with a particle in our universe? Would this mean there is an invisible, faster-than-light connection between the two worlds? Could we send a message through it? Probably not, because entanglement cannot be used to transmit information. But perhaps this cosmic entanglement causes statistical faint reverberations between universes. Perhaps the mysterious phenomena that astrophysicists call dark matter or dark energy, whose nature we do not understand, are partially nothing more than the gravitational shadow of another universe leaking into ours. In that case, the telescopes we point to solve the greatest mysteries of the universe may, unknowingly, be listening at the door of another reality. The search itself says as much about humanity as it does about the universe. Perhaps this infinite universes theory is just a mathematical mental exercise. Perhaps we are wrong. But what is the driving force behind this search? Is it just scientific curiosity? Or is there a deeper existential quest for an echo? Is it the desire to alleviate our own regrets by imagining that our choices had different outcomes elsewhere? Or is it the need to know that we are not alone in this vast, cold, and seemingly indifferent cosmos? That we have some kind of cosmic neighbors? The idea of parallel universes has become a modern mythology, beyond being just a scientific hypothesis. A creation story where the gods and monsters are replaced by quantum branchings and brain collisions. This story forces us to confront who we are and our place in the universe. If I have an infinite number of versions, who am I? Is it this specific moment, these specific memories, and the consciousness in this specific body that makes me me? If all possibilities are being lived out somewhere, then what is the meaning of morality, of good and evil? In a scenario where one version of me is the greatest saint and another the greatest sinner, does my moral effort here have any cosmic significance? Perhaps the meaning lies precisely at this point. In the face of infinity, the uniqueness and sacredness of the individual's experience. There may be an infinite number of worlds, but your consciousness is moving along only this single, unique path. This journey is not more meaningless because all other possibilities are being lived out. On the contrary, it is priceless because it is the only reality experienced by you. Ultimately, every window we open to the depths of space turns into a mirror we hold up to ourselves. As we look beyond the stars and galaxies to the misty shores of the multiverse, what we see may not be the ultimate alien, but the strangest and most unimaginable reflection of ourselves. The answers are not yet in our hands. Perhaps they never will be. But that does not mean we will stop asking, because humanity grows not by finding answers, but by asking questions. And the greatest question has been waiting silently in the stardust for billions of years. Where do we fit into this story? And more importantly, where does the story end? Or does it? Does it end? Perhaps we are asking the wrong question. Perhaps the real question is how it ends, or where it goes. In our universe, there are places where this question takes its most concrete, most terrifying, and most mysterious form. Black holes. They are the gravitational graveyards left behind when stars die. They have such a powerful gravitational field that beyond a certain point, not even light can escape the event horizon. So what happens to something that crosses the event horizon? A book, a planet, or even a person? According to our traditional understanding, its mass is crushed into a single point, an singularity of infinite density, and destroyed. But quantum mechanics tells us that one of the most fundamental things in the universe can never be destroyed: information. The arrangement of the atoms that make you you, the order of the letters on the pages of a book, all of this is information. And according to quantum laws, this information cannot be erased from the universe. This is the famous black hole information paradox, which giants like Stephen Hawking spent decades working on. Can a black hole violate this fundamental law? This paradox pushed physicists to their most daring thoughts. If information is not destroyed, where does it go? One of the ideas Stephen Hawking proposed in the final years of his life was that this information is encoded on the event horizon of the black hole, like a hologram, in quantum fluctuations called soft hair. The information wasn't actually destroyed. It was just recorded onto a two-dimensional surface, written onto a cosmic hard drive, so to speak. But there is another, more radical possibility. What if black holes are not dead ends leading to singularities, but back doors in the software code of existence? What if the information that crosses the event horizon passes through a bridge to a completely different place, to another reality? According to this theory, a black hole could actually be a wormhole connected to a white hole. The black hole that swallows everything in our universe could be a white hole in another universe, spewing everything out, a Big Bang source for that universe. In this case, a family tree of universes is formed. Black holes formed in parent universes give birth to baby universes. Our Big Bang might be the other end of a giant black hole inside a much older universe that existed before us. In this scenario, the matter and information of lost stars and galaxies that fall into a black hole become the seeds of a new universe. We may be living inside a new volume written with the ashes left over from the burned books of a cosmic library. This idea not only solves the information paradox, but also provides a cause for the beginning of our universe, the Big Bang. It explains not how everything came from nothing, but how one thing transformed from another. The idea that universes are born from black holes within a parent universe is a model that at least tries to remain within the framework of the laws of physics as we know them. But what if the real question is about the laws of physics themselves? We look at these laws as the rules that describe the workings of the universe. But where do these rules come from? Who wrote them? This thought leads us to one of the deepest, most dizzying areas at the intersection of physics and philosophy, the mathematical universe hypothesis. According to proponents of this hypothesis, our physical world is nothing but an abstract mathematical structure. That is, our universe is not described by mathematics. Our universe is mathematics itself. Everything from the atoms your phone is made of to the neural firings that form the thoughts in your brain is fundamentally composed of mathematical relationships and structures. If this is true, if our reality is just a certain mathematical structure, then the question arises, where are the other mathematically consistent structures? For example, consider a mathematical structure corresponding to the four-dimensional, three-space, one-time, space-time geometry of our universe. What about a mathematical structure based on a geometry with 5, 11, or 26 dimensions? Or a completely different algebraic structure that leads to entirely different fundamental particles and forces? According to the mathematical universe hypothesis, if a mathematical structure is sufficiently complex and consistent, it exists, not just as an abstract idea, but as a physical reality hosting its own conscious observers. This takes the multiverse idea to a whole new level. We are no longer talking just about different versions of our universe or baby universes born from ours. We are now talking about universes so alien and different we cannot even imagine, where every conceivable consistent mathematical structure is embodied. A universe where time has two dimensions. A universe where cause comes after effect. Universes where logic and geometry are built on entirely different foundations. All of these exist as formulas in the abstract mathematical world called the Platonic realm of ideas. And according to this hypothesis, this existence itself grants them physical reality. In this case, our universe is not special. We are just one of the plays on an infinite theater stage where all possible mathematical scenarios are acted out. And the script for this play is written with numbers and equations. This is the most comprehensive multiverse model that can exist, and also the most unsettling. Because in this infinity, we have no reason to say that our reality is more real than the others. Let's pause for a moment and take a breath. Infinite mathematical realities, universes born from black holes, quantum worlds branching with our every decision. These ideas push not only the limits of the human mind, but also the limits of science. And here, we must confront a fundamental principle that lies at the heart of science: falsifiability. The great 20th century philosopher of science, Karl Popper, argued that for a theory to be considered scientific, there must be a potential experiment or observation that could prove it false. For example, Einstein's theory of relativity predicted that starlight would bend as it passed by the sun. If this bending had not been observed, the theory would have been falsified. But it was observed, and the theory was strengthened. But what about multiverses? Can we design an experiment that can observe a reality beyond our universe, to interact with it? Can we prove that those universes do not exist? Most physicists would agree that the answer is no, and this point lies at the center of one of modern physics' greatest philosophical crises. If a theory proposes entities that cannot be tested or falsified, is it still science, or is it a kind of sophisticated metaphysics? Critics of the multiverse hypothesis argue that this is a dangerous path. They argue that science should remain limited to the evidence-based, observable universe, Otherwise, it becomes no different from theories that propose the existence of ghosts, angels, or invisible dragons. If we can explain any observation by saying, "Oh, that's just how it is in our universe. It's different in another," then the theory can explain everything, and a theory that explains everything, in fact, explains nothing. On the other hand, proponents of the hypothesis argue that science evolves. According to them, theories like string theory or eternal inflation are the inevitable mathematical consequences of well-established foundations like quantum mechanics and general relativity, which we have proven in our observable universe. If our equations persistently point to the existence of other universes, would it be a form of dogmatism to ignore them simply because we cannot see them directly, like refusing to believe in Jupiter's moons because one lacks a telescope? Isn't that an attitude contrary to the spirit of science? This debate is about the very nature of science itself. Perhaps we need to redefine what we call observation and proof. Perhaps the proof of the future will not lie in a telescope image or a particle collision result, but in a theory's internal consistency, its mathematical elegance, and the logical explanations it provides for the unexplained oddities in our universe. This is a risky but exciting dance in which science carries its search for proof into the darkest corners of the unknown. This deep intellectual struggle between science, evidence, and falsifiability brings us back to the same starting point: ourselves. The observers. If the multiverse theory is scientifically weak because it cannot be tested, then what meaning should we attribute to the only thing we have left, our own existence? How do we explain the fact that the universe is so incredibly finely tuned for life? This brings us back to a concept we have touched upon, but now must dive into deeply: the anthropic principle. There are two main interpretations of this principle, and the difference between them is as vast as night and day. The first is the weak anthropic principle. This is nothing more than a selection effect. It states, the properties we observe of the universe must be those that allow for the existence of observers like us. This is a kind of tautology. To the question, why are we in such a lucky universe? It answers, because if we were in an unlucky one, there would be no one to ask the question. The multiverse hypothesis is the most natural partner for this weak principle. There are infinite universes, and we just happen to be in one of the habitable ones. But then there is the strong anthropic principle. This is much more radical and controversial. It states, the universe must have properties that allow for the emergence of consciousness at some stage. This is an almost teleological or purposeful claim. It speaks as if the universe has a purpose, and that purpose is the creation of conscious life. This idea, according to some physicists, seems to return the universe to a human-centered cosmos. But for some, it might point to a connection we do not yet understand between the deepest laws of nature and consciousness. An even more advanced hypothesis is the final anthropic principle. According to this principle, intelligent information processing ability, once it emerges in the universe, will never be destroyed. Even as the universe expands and cools as stars die, intelligence and consciousness will somehow find a way to exist and process information, and will exist forever. This means that life and consciousness are not a byproduct of the universe, but its ultimate destiny. From this perspective, parallel universes are like a pool of possibilities, and consciousness is an explorer traveling through this pool, searching for paths to carry itself into eternity. This redefines humanity's place in the universe. We are no longer a handful of carbon that exists by chance, but perhaps a part of the universe's attempt to know and understand itself. Although this leans more towards philosophy than science, it brings us to one of the ultimate questions. If the universe has a purpose, and that purpose is consciousness, then what is consciousness itself? Consciousness. The final, incomprehensible fortress we arrive at after our entire cosmic journey. We do not know how a piece of meat, the brain, can experience colors, feel music, know love, and reflect upon its own existence. This is science's hard problem. But what if consciousness is not just the result of a complex computation inside the brain? What if it is the missing key to the multiverse puzzle? This is an idea that roams the most speculative frontiers of physics and neuroscience. Thinkers like Roger Penrose argue that consciousness cannot arise in a classical Newtonian brain, that its origins must lie in the strangeness of the quantum world. According to them, in protein structures in the brain called microtubules, quantum superpositions, the state of a particle being in multiple states at once, can be maintained for much longer periods than we understand. The moment of consciousness is the moment this quantum state collapses, meaning one of the countless possibilities is chosen. Now let's combine this idea with Hugh Everett's many worlds interpretation. According to Everett, there is no such thing as quantum collapse. Every possibility becomes real in its own universal branch. So what if our consciousness is like a pilot choosing which path to take at this branching point? What if what we call our subjective experience is simply the act of charting a coherent course for ourselves through these infinite quantum paths? This elevates consciousness from a passive observer of the universe to an active participant, even a creator. We may not be choosing reality, but we may be charting the course of which reality we experience. In that case, could strange feelings like déjà vu be faint echoes leaking from the experience of another me on another quantum branch? Could our dreams be the free wanderings of our consciousness in this network of possibilities? This is a highly speculative idea, impossible to prove. However, it raises the possibility that consciousness may be the only thing that can cross the supposedly impassable wall between different universes. Perhaps these walls are impenetrable to matter and energy, but not to information and consciousness. Perhaps in the deepest moments of meditation, in intuitive enlightenments, or in moments of artistic inspiration, the human mind momentarily touches that infinite ocean of possibilities beyond its own branch of reality. Ultimately, we looked outward to search for the universe, but perhaps the greatest secret was always inside the place we were looking from, the observer itself. An infinite number of universes and an infinite number of me's. Perhaps they are all nothing more than different faces of a single, indivisible cosmic consciousness. And that consciousness, while listening to these words right now, is making yet another attempt to understand itself.